So heroes, you don't attend the Power BI hour, the BI Power Hour, and you want to look at you want to watch, you want to attend the DAX evaluation context session. So welcome. My name is Marco Russo. I'm here today to describe how the evaluation context works in DAX in 1 hour. So believe me, it's hard to describe in detail everything in a way that should be, relatively easy to understand. So for some of you, it will be a recap. For some of you, it will be something new. And in that case, I don't expect you to capture all the details that we will see, but I will try to be as clear as possible. And if you have some question in the meantime, don't be afraid to raise your hand. This could be a complex topic, so I accept the questions during the session. Don't be afraid to ask. So, what is the evaluation context? When you write a DAX expression, the DAX expression is executed and provides a result. And even though you write the very same DAX expression, in every cell of your report, you see a different number. Why? Because something happens behind the scenes, and even though you wrote a simple DAX expression, a simple DAX query, in reality there are other elements that affect the result of the calculation. These elements are what we call the evaluation context. And the evaluation context is made by two main concepts, which are the filter context and the row context. But we have one important element, which is the context transition that can provide side effects in what we observe as a result of our evaluation. So we need to introduce some theory in what we see, because of course the evaluation context requires some background, theoretical background that cannot be described just looking at some code. And the idea is the following. Let's say that I have a measure. A measure is a simple sum where I sum one column of my model. So this is the simplest measure that you can create in DAX, sum one column. When I execute this measure in Power BI, in Excel, in any reporting tool, I get, as a result, the sum of all the rows of the table that has that column. The total sales here is the sum of all the rows of the table. But as soon as you introduce some other element in the report, for example, you create a matrix or you create a pivot table, and you included the product color in the rows, then every row has a different value. And you say, Marco, it's normal, because we want to see the sum of the sales for each color. OK, this is the natural description of what we want to do. But why the measure that we wrote, the sum of sales amount in the sales table, is actually only considering a few rows of the sales table, while the filter that we are potentially applying is on another column of another table. So what is exactly the technique that produces a different result? Well, this technique is the filter context. The filter context is something that implicitly filters the expressions that we write because we apply the sum filter. Now, how can we represent these filters? Because the first idea is that, OK, if I look at the user interface of a report, I can see that we have elements. And in Power BI, this could be complex, because in Power BI, you have every visualization can potentially affect the result of other visualizations. Everything cross-filter everything else. You can also have page filters, visual level filters, report filters. So you have a lot of filters going on. How can we represent this? Well, let's consider one cell in this visualization, the value that you see for Contoso. And the measure that we use to compute the sum of the quantity that you see in that cell is always the same expression, sum of sales quantity in this case. Why this is reducing the quantity to 376 instead of a bigger number? Well, if we evaluate the filter context active in that particular cell, we could describe this the following way. The filter context can be represented as a set of filters, where every filter is just a list of values for one or more columns. The first filter that we have, someone clicked on the bar chart for the year 2007. So there is a filter that says calendar year can be only 2007. And then if we look at the report, there is a slicer that has a multiple selection. So there is another filter in the filter context that says education can be only one of these two values. And finally, the quantity value that we highlighted is in a particular row of a matrix. And this matrix has a value of one brand in that row. So the third filter in the filter context says brand must be Contoso. So the way we describe the filter context is through list of values. Okay? Why this is important? As you see, I'm not saying the filter context is a condition, because the filter context does not include conditions, contains only, from a logical point of view, a list of values. A filter in the filter context is a table. In other words, if we consider a filter context where we have two filters, every filter is a table that could have also more than one column. For example, imagine you want to apply a filter that says, okay, I want to filter December 2006 and January 2007. If you have a column month with 12-month names, filtering by month is not enough. You need to combine the filter over year and month into the same filter, because if you create two different filters, you say the year could be 2006 and 2007, and the month could be January and December, what you obtain as a result? 4 possible months. You combine them. Whereas if you define a single filter that has 2 columns, you can specify only certain particular combination of values. By the way, Power BI doesn't allow you to create such a filter. You can do that in Excel. In Excel, if you create a hierarchy that says year, month, and day, for example, you can select only one month in one year and another month in another year. If you think about this, by default, Power BI doesn't have a tool to do that. You don't have a UI in Power BI that allows you to say, I want to only see December 2006 and January 2007. There is a custom visualization to do that if you want. But DAX allows you to do that, but requires at that point to have a filter that has 2 columns. Now, in order to avoid the confusion between tables and filters, because a filter is a table with rows, we can use different names. So we can call tuple the list of value for a set of columns, like this one. In other words, one row in one filter is what we call a tuple. We don't use this name often. But the table that we inject into the filter context is something that from here in after I will call a filter. Actually, I already used this name. But when I say filter, one filter is one table. And one filter context is a set of filters. So it's a set of tables. So the filter context that you apply for a calculation is a set of tables that have values for one or more columns. The filter context is important because applying the filter context to a calculation is extremely fast. Okay? This is important. And this is the reason why this is the preferred way to obtain calculations in DAX. Applying a filter, applying 2 filters, modifying the filter context, and then executing our calculation, rather than getting a table and scanning the table row by row, applying the filter row by row. This is slow. Don't do that. However, the evaluation context is made by 2 parts. We have the filter context, we have the row context. What is the row context? Whenever you write an expression, for example, in a calculated column, what is a calculated column? If I open my example here, let me see if I remember what is the right. Okay, perfect. So if I go here, and I go in one table here, for example, sales, and in this table sales, I create here a new column. You can write here, for example, you see that we have quantity, unit cost, net price. The quantity could be 2, 3, 4. So actually, what is the amount for one line? I can write a column called the line amount, where I write quantity multiplied by net price. As you see, IntelliSense is suggesting me to get a column from the current table, and I have access to all the columns of this table because we have a current row, which we call a row context. The row context is something that exists only in particular conditions and allows you to write a column reference, which is a DAX syntax that says table column. And table column has a meaning when you have a row context, and the meaning is, give me the value of this column in the current row of this table. What is the current row? The row context. So I write this expression, and this expression is evaluated for every row of my table, because in each row there is a row context that says what is the row that will resolve the column references that you write in this expression. Now, I wrote my expression this way using a calculated column, but in reality, it's not a good idea to create a calculated column and then computing a sum over that, because I can obtain the same result without increasing the size of the data in memory by using a measure. When I define here my measure sales amount, let me write this measure from scratch. So my measure could be written like SumX. SumX has two arguments, a table, and for each row of this table, I want to execute an expression. So if I iterated the table sales, and for each row of sales, I write exactly the same formula that I would have wrote in the calculated column, I can write quantity multiplied by net price. Once again, because this syntax is written in the second argument of SumX, and the second argument of SumX is an expression that is executed in a row context, I can use column references for this table. Now, sometimes somebody asks, Marco, how can we know what are the functions that have arguments executed in a row context in DAX? I have a bad news and a good news. The bad news is that this information is not provided in a clear way in IntelliSense or in the documentation provided by Microsoft. I can say, oh, this expression should be computed for every row of the table, but actually I don't have a clear description of this. The good news is that if you go to this website, DAX Guide, this website has additional information for each function, which allows me to say, for example, if I go to SumX, you see that the expression SumX is executed in a row context. You see this green button here, which says simply that this expression is executed in a row context, which is exactly what I want to say. When you have an argument in a DAX function that is executed in a row context, you can use column references that otherwise will not be valid. Okay? So let me go back here. And let me go back to the slides 1 second. So here we go. So the row context executes the evaluation row by row. For every row, it executes this. So why the filter context affects the calculation of our formula? What is going on here? Well, if you think about my formula, so this is just the animation that shows you what happens row by row. If you think about the sum of the two, row context and filter context, why the two work together? Let me describe this. So here, I have this expression, SumX, sales, quantity, net price. And this is sales amount. My measure sales amount is executed in my report here, in each cell here. And each cell here has a different filter context. So think about this. What is the filter context of this cell? Let me select 2007 and green. What is the filter context of this cell? Well, the way I describe the filter context is exactly the following, and I like to use this approach here. My filter context is this. If I want to think about what is the filter context, I had a slicer that had two values, 1 and 2. This is one filter in the filter context. The second slicer is 2007. That was the year. The third filter in the filter context was, if I remember well, the color green. Okay? Now, how these three filters affect my calculation, my SumX? Well, if I go back to my definition of the SumX, the measure sales amount here has a table expression. And the table expression in this case is simply a table reference. But this table does not retrieve all the rows of the sales table. It retrieves only those rows in sales that are visible through the current filter context. So it is sales that is affected by the filter context. Whereas whatever I wrote in the second argument is executed in a row context, and at that point the filter context doesn't matter because I don't have aggregations. The filter context affects aggregations, table expressions, not column references. A column reference is valid only when you have a row context. Okay? So this is the way we can recap very quickly how row context and filter context work. Now, when I have a model, however, I have a model with tables and relationships. And these tables and relationships have an effect to my model. And sometimes, however, some behavior is not totally clear if we don't introduce this concept, which is the concept of the expanded table. So before going here, let me go back 1 second to the model, because I want to highlight in this model there is this situation. This is the model that I used in the example we made so far. And you see that I have a central table here, which is called, let's see, this one. This table is called sales. And I was iterating sales, but then I was applying a filter over calendar year in date, and I was applying a filter over color. Now, why, if I apply filters in different tables, these filters affect my calculation? Because a filter applied to the filter context automatically propagates to other tables in the model through relationships. A relationship is a tool in DAX that transfers a filter between tables. And this transfer happens only following the direction that you enabled here. By default, and as a best practice, we only transfer filter from one to many. We can enable a bidirectional filter, but it should be done only in particular cases where we know exactly what we're going to do. And so by default, when you apply a filter over the product table, for example, the filter is automatically propagated to the sales table. Okay? So this is the default behavior of the filter context. The filter context automatically propagates through relationships. But you see that the presence of these tables sometimes has some effect in our calculation. And what is this effect? Let me describe. What we have is this concept. Every table that we have in the model has a definition of a base table in the model. So the base table in the model is exactly the table that you loaded in the model. But whenever you create a many-to-one relationship between one table and other tables, you define a potential join between your base table and other tables. So if you look at the table and you imagine to flatten the table, joining all the other tables that you can reach through many-to-one relationships, what you obtain as a result is what is called in the DAX world as an expanded table. So the presence of the relationship between, for example, product and product subcategory defines these two concepts. Product is a base table made only by the columns of product, but the expanded table products includes all the columns of products plus all the columns of subcategory. Just like you do a left join using the relationship. And when we consider this, this doesn't happen only for the first relationship. If you have product, subcategory, category, 3 tables, the expanded table product includes all the columns of product plus all the columns of subcategory plus all the columns of category. Why this is important? This is important because every time you apply a filter into the filter context, you can apply a filter filtering 1 column, 2 columns, 3 columns, and you filter only the columns that you filter. But whenever you specify a table as a filter in the filter context, you always reference the expanded table, not just the base table. And yes?
Why when you create a relationship, usually the cardinality says 1, when you say 1 to many, it says single. What is the best option, single or both?
Okay, I repeat the question just for the recording. The question is, when I have a relationship in the model, like I shown here, the relationship is defined this way, as a 1 to many, and you see that the cross-filter direction could be single or both. By default, when you create a new relationship, a 1 to many relationship is always single, and my strong suggestion, keep it single. There are cases where you might want to enable the bidirectional filter for particular reasons. The best practice is to not enable the cross-filter direction as a bidirectional in the model, unless you know exactly what you're doing and what are the side effects of that. Because usually you want to enable a bidirectional filter for some specific calculations, and you can obtain this result by using a specific function in a calculus statement, which is cross-filter. Cross-filter is a way that enables a bidirectional filter for a specific calculation. This way, you obtain the effect that you want for that calculation without having sometimes undesired side effects on other calculations. If you enable the bidirectional filter in the model, every calculation will be affected by that. And you might have 2 kinds of problems. One is performance, and the other is undesired numbers that you obtain as a result. So why I mentioned this thing about the expanded table? Because this is something that will come useful when we will see how we can manipulate the filter context. So I've shown you what the filter context is from a conceptual point of view, but the power of DAX is the ability to modify the filter context before executing some actual calculation. If you want to get performance in DAX, you have to manipulate the filter context and then execute a calculation, because manipulating the filter context before the calculation is the more efficient way to actually query the data that you have in the model. If you do something different, you might end up in having a slow performance because you basically apply more complex and long calculations over data that is materialized in memory. Like, imagine you create more temporary tables that are unnecessary. Whereas if you manipulate the filter context, you probably reduce this requirement, and you obtain better performance and more control. Now, calculate works this way. When you write, for example, a calculus statement for a measure called red sales, how do you write red sales? Well, I can write the calculation this way. So if my sum x sales quantity by net price multiplied by net price is my calculation of the sales amount, I can embed this calculation in the first argument of calculate, and calculate can apply 1 or more filters to the filter context before executing the first argument. So the first strange thing is that calculate must be read in a different order. We had to read usually the filters before the first argument. So the first argument is the last one to be evaluated. And the calculate function that you see in the slide is applying a filter to the color column of the product table, and then it evaluates the calculation. But calculate, my measure, is executed in a filter context, because we said, oh, when I write a measure and I use my measure in my model, actually my measure receives an initial filter context defined by my slicers, my other visualizations, and so on. So we call this the outer filter context. So the outer filter context is the filter context we have outside of calculate. Calculate can generate an inner filter context, which is the result of the outer filter context modified by the arguments that you write in the second, third, and following arguments of calculate. At this point, in this inner filter context, calculate executes the expression. In this case, sum x is an iterator that for each row of sales evaluate quantity by net price in a row context. In a row context of how many rows? Those rows that are visible in the inner filter context. So you can see that step by step we can examine exactly what is going on. Now, in this case, I wrote a measure that says product color equal red, which means that I want to add into the filter context a filter over the column color of the table product. And this filter that I create has only one value, red. The result of my new filter in the filter context is not a condition, a logical condition, but is a table. A filter is a table. In this case, it's a table that has one row, one column. But if you write product color in red, blue, green, this statement generates a table that has 3 rows. Okay? So my new filter is added to the filter context, changing the way the evaluation will be computed. So filters are tables, and we usually use this syntax, which is a syntax that we technically call a predicate. A predicate is a logical condition, a Boolean condition if you prefer. But DAX, in order to execute this code, actually generates this code instead. DAX transforms your compact syntax into another DAX expression that generates a table that has one column, product color, and as many rows as those rows that satisfy the filter that you wrote. A filter is a table. Whenever you write a predicate, you're just writing a predicate that is translated into an equivalent table expression, generating a table with a list of values that you want to filter. If I write product color equal red, it's easy. But let me just, if I have time, yes. Let me show you one thing. Let's do an exercise together. Now I have this visualization. For example, let's go here. This is by product, Azure. Okay, fair, fantastic. So my sales amount is my calculation that we have seen before. So quantity multiplied by net price. If I create here a measure, red sales, okay, red sales, usually the way we create the measures is not by writing sum x, blah, 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 but the easiest way to create a measure is to call another measure, for example, sales amount, applying some filter. Because this way we reuse an existing business logic in our measure. And for example, I write here color equal to red, okay? What happens if I do this? Think about this. If I include this red sales here, this is interesting. Look at the result. This is always blank. And here we always have the same value of red. Why? What is happening? Let me describe. Think about this. We have, let's consider this cell. What is the filter context of this cell? Let me draw this. So we have AdventureWorks in blue. So the filter context for the cell is exactly this one. Filter context, one filter is blue, which is the color, and the other filter is I think brand, that was AdventureWorks. This is the initial filter context. My calculator created a new filter, color red. Now this filter goes into the filter context, but because there is already a filter over the product color column, the existing filter over the same column is removed, and the new filter replaces the previous filter. When you apply a filter to the filter context, you overwrite an existing filter over the same column, because we filter by column. So the result of this is red AdventureWorks, right? So if we go back to our report, you see that in every cell we start with two filters, one brand and one color, but we always overwrite the color using our red color. So why we have blank here? I think we do the same. We do the same. We replace the current color with red, keeping the current brand. And guess what? What is the value of red for a datum? You don't see red. There are no sales for products that have a color red and a brand red. So it is working. I'm replacing a filter with another filter. When you apply a column filter, you replace that filter with another filter. What if this is not what you want to do? In case I don't want to override the filter, I can use keep filters. Keep filter says, I don't want to override the filter. I want to apply this filter, keeping any existing filter. If you do this, you see that the result is slightly different, because now I have the value of red only here. All the other values are blank. Why? Because if I go back to my filter context, only the last thing that this removal didn't happen. So my final filter context is the following. I had an initial filter context made by, for example, blue and AdventureWorks. So this was the color, this was the brand. My new filter is red. And what is the problem? How many rows in the sales table satisfy both filters? None. A product can be either red or blue. So basically, when you have multiple filters in the same filter context for the same column, it's like you have an end condition between these filters. Okay? Keep filters, keep the existing filter, because you don't want to remove it. And so this is one of the tools that you have in DAX to control what happens into the filter context. What is my note here? Okay? So internally, this is what happens. And the problem is, if I have a condition that requires two different columns, well, a condition that requires two different columns is a condition that requires more than one column in the filter. And if you try to write this condition manually, you get an error. For example, let me go back to my example, and let me show you a couple of other examples that I could write. Here, I could write, let me remove this and this. I could write a measure called big sales. And big sales is equal to a sum x of sales amount. Sorry, not sum x, sorry, calculate of sales amount. And let's say my initial definition of, sorry, I didn't want. My initial definition of a big sales is any transaction that has any transaction that have at least 2 as a quantity. So let's say the quantity must be sales quantity must be greater than 1. Okay? So if I show you this value and I ask you to understand what I'm doing, what is the filter context here? The initial filter context has 2 filters, right? Which are AdventureWorks and Brown. So let's do this. So I go to my whiteboard, and I draw my filter context that is made by two filters. One is AdventureWorks, and the other is brown. Okay, this is the color, this is the brand. But my calculus statement created a new filter over sales quantity. What should I write here? Think about this. I wrote sales quantity greater than 1. This time I didn't write equal to, right? And the problem is that this filter is 2, 3, 4. A filter could be expensive. A filter equal to is always a cheap filter, but a filter greater than, other than 0, expensive. Now, the engine usually is smart enough to optimize later this. But from a logical point of view, this is the way you have to think about the filter context, because sometimes the filter is materialized this way and can be expensive. I'm lucky. I know that in my quantity column, I have only 2, 3, 4. That's fine. Okay? And if my condition is by quantity, it just works. And the number is smaller than the other. So far, so good. Now, why I was saying I may want to use key filters. Imagine that someone applies a filter over quantity. So if I show the hidden columns here, I apply a filter over quantity in the page filter, for example. So I go here in page level filter, and quantity has to be greater than, less than 4, okay? If I apply this filter, look at what happens at sales amount. Sales amount will change, big sales will not change, right? Which is quite strange, because at this point, we might have a condition. Imagine that I write 3 here. I don't have any strange condition here, but in some case, I could see numbers that look strange. What can I do to apply this filter to big sales too? Well, big sales should use keep filters, because if I don't use keep filters, my filter says quantity greater than 1 will overwrite the filter, the page level filter. Whereas if I use keep filters, now I keep both, and so I am sure that big sales will be always a subset of the existing filters. So this is something that you have to keep in mind. But usually for a single column filter, this is not a big issue. So let me introduce the other problem. In reality, I go to my manager says, no, Marco, this is not good. I want to filter those transactions that have an amount that is greater than 1,000. What is the amount? Okay, the amount is something I could obtain with a measure, but is expensive. So the best way to do that, it would be to reproduce the net price, the sales net price, multiplied by sales quantity greater than 1,000, for example. I could say, Marco, my manager says, Marco, the transaction that for each row has a value greater than 1,000 is what we consider a big sale. But in order to save memory, I didn't include a line amount column, because if I had a line amount column, it would be a filter over a single column, easy and best practice. But in this case, I want to create a filter over 2 columns. Guess what? I cannot. If I try to write the filter this way, I get an error. However, you say, wait, well, I can write a filter providing a row context that makes this filter valid. But what happens if you write this? The code works. This filter works and produces a result. But let me describe the filter context for this cell. AdventureWorks blue. Let's draw this. What is the filter context here? Oh, the filter context is we have AdventureWorks, which is a brand. We have blue, which is a color. And then we have our filter for sales. Sales is a table that has all the columns of the sales table plus all the columns of, so if this is sales, then we have product, then we have date. Because every time you reference a table in the filter context, you're referencing the expanded table. Moreover, how many rows you have? Many. You see the problem? Filtering a table is a way in DAX that describes a filter that is very, very, very expensive. There are very rare cases where you want to do that. Most of the times, you can obtain this result by simply filtering using not a table, but just the two columns that you have. All net price, all sales net price, and the sales quantity. Now, I create a table that has only the existing combinations of net price and quantity. I filter through this table that has only two columns, and I obtain only the existing combination of those two columns that can produce this number. If I do that, my calculation produces apparently the same result, but at which price? Let me describe. The initial filter context is always the same. Filter 1, filter 2. One is brand, one is color. Okay? But then my new filter has only two columns, quantity and price. And I have only the list of the unique combination that satisfy this condition. This filter is cheaper and is more, let's say, DAX friendly, because we filter columns, not tables. It's always better to express a filter this way.
Can you accomplish that using all? Did I see that right? You accomplished the all function, is that what did that?
Sorry, I don't understand the question. Can you?
Where you have all right there.
Yes.
That's the function that accomplished the more efficient calculation here?
It depends. The question is this the more efficient function? Usually yes, because even though you may say, but Marco, this way I get all the possible combination of net price and quantity, even though I have an existing filter in the table, you are right. But remember that you will execute this evaluation for every cell of the report. And every cell of the report might have a different filter context, which would require to generate this table for every cell. If I use all, I ignore this filter, and so this filter is created only once, and it is applied over the existing filter context. But there is only one particular problem that you have to consider. If I write the filter this way, I overwrite any existing filter over net price and quantity. And guess what? I have a filter I don't want to overwrite. If you use a filter table, like I did before, you inherit the existing filter, and in that filter you apply the filter. Now I'm applying a filter that overrides the filter. So if I want to make sure that I obtain the same semantically equivalent result of the previous table, in this case, I have to use keep filters. Because if I don't use keep filters, the existing filter over quantity will be removed with this syntax, whereas it was kept in the filter context in the other syntax. Okay, so this is just to explain that if I'm creating a new measure from scratch, I don't care, because if I do some mistake, I will erase this later. But if you change an existing measure and you don't want to break existing reports, you have to make a transformation that is semantically equivalent, like this one. Okay? Now, let me go back to the slides. Here we go. Okay, so what we have seen is that I could filter a table, but the table filters are bad for the reason that I try to describe in a visual way. Because if you think about the table is big, it's huge, it's an expanded table, it's expensive. We can filter using a table that has only the columns that we need. Yes, creating this table could be expensive. It depends on the granularity of the columns of the table, by the way. But usually it's the cheaper way. We could consider alternatives like using summarize or other techniques, but it's something that I will do in a very, very specific conditions. Otherwise, this is usually the best syntax. Also because the engine has been optimized for these syntaxes. So basically, most of the times I get a good result in terms of performance. So this is a column filter. If I explicitly reference 1, 2, 3 or more columns, is a column filter. But when you write a table name, you're writing an expanded table filter that, as I said, it could be much more complex. Okay? Now, I can manage to not only add new filters, I could apply changes to the filter context, for example, removing filters. And there are other functions that can be used only in calculate that are called the calculate modifiers. I used one, keep filters. Keep filter changes the behavior of how a filter is applied to the filter context. Use relationship and cross filter change the current relationship and the direction of the propagation of a filter context in the filter context. So these are specific filter modifiers that change the behavior of calculate. But there are a set of functions that are always filter modifiers when they are executed as the only function in a filter argument of calculate, and are all the functions that start with all. For example, when I write this syntax, all removes the filters that exist in a column. What does it mean? If I write this syntax, all column, I remove a filter from the filter context. I do not create a table with the list of all the values. Okay? So in other words, what we're saying is that if I create here, imagine you want to create something like a percentage of sales. Okay? A percentage of sales will be the division between the sales amount and a measure that I still have to create that I will call all sales. So in order to make this percentage working, I need to create a new measure that I will call all sales. And all sales is equal to, for example, calculate of sales amount without the table, comma, and I want to remove the filter from the sales table. What happens if I write this? If I move this here, you see that for every row, and I can also show the percentage at this point, so you see that oops, made a mistake. I didn't want to do this. I wanted to apply the percentage here. Here we go. So you see that this number, this percentage, is obtained by dividing this number by this number. So the key is, how do I obtain this number? Using the calculate that you see here. So let me describe once again what happens in the filter context for this cell. We have one brand, one color in the filter context. So the initial filter context is always the same. Filter context, one brand, one color, two filters. Easy. One value here. My calculator says all sales. You see, Marco, you write a big table because all sales seems to be a table that has all the columns of sales. No. What I'm doing is not this. So let me remove this. What I'm doing is that all says remove the filter from every column that belong to the sales expanded table. So all the columns of sales, all the columns of product, all the columns of date, all the columns of customer, because guess what? Sales has connection to all the other tables. So the expanded table has everything, usually, because it's a star schema in this case. So when you write all, you actually remove filters, and removing a filter is a very efficient operation because we actually don't build new indexes, we just remove existing filters. So it is usually a non-expensive operation in our calculation. All except does something that is very similar. All except removes the filter from all the columns of a table, but one column or two columns. So all except says remove from everything, but keep, if there is a filter in country region, keep the filter there. You can write a syntax this way, which is not the same as saying all and then values. Think about this. All customer values customer country region. Values customer country region is a syntax in DAX that provides the list of the values that are visible in the filter context for that column. It's a table. And if I write both conditions, all removes filter and values apply filters. Why I'm saying is not the same? Well, if you had a filter over country region, it is the same. But imagine that you have a filter over continent. Continent is the list of the countries of that continent. But if I write all except customer country region, all except customer country region, I remove the filter from all the columns, I keep the filter in country region if there is a filter over country region. Guess what? I don't have a filter over country region. I have a filter over continent. So the result is I see all the cities, all the countries. But if I have a filter over continent and I execute all n values, I remove the filter from the customer, and I restore the filter for country region column that is visible in the filter context. And guess what? I get the list of all the countries in the current continent, or in the current city of the customer, or in the current area. I don't have to know where the filter was. I just want to I want to preserve the countries that are visible in a direct or indirect way in the filter context. And this could be useful in certain calculations. Now, filter context and row context can be controlled this way, and calculate can enable you to control the filter context, but calculate can also apply an operation that involves the row context. And the row context is not a filter. The row context iterates. And in this case, SUMX, customer, sum of sales amount, will produce a strange number, because we're not saying we want to sum the amount of the sales for each customer. We are saying sum sales amount for the entire table. Why the row context does not get the current customer? Because we said only the filter context propagates through the relationships. The row context ignores the relationships. And when you write this syntax, SUMX iterates customers, sum sales amount aggregates the amount column in the sales table. There is nothing saying I only want to filter the sales for the customer. We can obtain this behavior by writing calculate. If you write the code this way, you are saying, for each customer, execute this calculate. Calculate transforms the current row context into an equivalent filter context. At this point, the sum of sales amount is an aggregation that happens within a filter context that is restricted by just one customer. And this code works as we might expect, right? So usually, the context transition works this way. And the context transition is implicit whenever you write a measure reference. So let me go back to the example so that I can show you a demo of this. Let's say that we have here, for example, here we have, let me remove the receipts amount, and let's include only sales amount. We can do the example using, why this is sorted this way? Oh, that's just bad. Okay, let me fix this. Why did we have the date table that is not sorted correctly? So we just have to fix this, sorting by column, month number. Much better. So I have this visualization where I can see, okay, for every month I see a number. What happens if I create here a measure that says, okay, I want to see the average by customer for each month or for each, I can write average X. So average sales customer is equal to average X. For each customer, I want to retrieve the sum X of sales quantity. This is a mistake, okay? I'm repeating the same mistake that we have seen in the slides, because I'm writing sum X over sales, but I'm not transforming the current row context into a filter context. So this is a measure that produces a wrong number. If you look at the number, how is it possible that the average by customer is identical to sales amount? You see the problem, right? Because for every customer, I'm computing the same number, and the average by customer is the same number. What I want to do internally to that calculation, I want to retrieve only the sales for the current customer. For those of you that know DAX, there is an alternative that is this. Related table gets give me the rows in sales following the one-to-many relationship from the current customer. But a better way to do this is using calculate. If I use calculate, I'm saying transform the current row context in the customer table into an equivalent filter context. And at this point, the entire calculation, sum X, blah, 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 is executed for a single customer in the filter context. And this produces a result that makes more sense. The average by customer, month by month, is a smaller number than the sales amount. Now, when you have this, if you remember, this expression was sales amount, right? I can write this. And if I write this, of course, I obtain the same result. However, it could be unexpected is that if now I remove calculate, the result is still the same executing the context transition. Still the same value. Why? Because whenever you have a measure reference in a row context, there is always an implicit calculate outside. There is always a context transition. So a measure reference, and this is the reason why we want to be very explicit when we have a measure reference. We want to identify it without writing the table name before the measure name, because a measure reference in an iterator where you have a row context could be expensive. This is not for free. If I really want to do this calculation, instead of computing the sales amount customer by customer, it would have been smarter to get the sales amount of all the customer, dividing it by the number of customers. Because this way I avoid to do many context transitions. But this is just for the optimization part. For the average, of course, it was possible. For other calculation, it could be not possible. Now, you have to pay attention to one very common mistake. What happens if I call a measure reference iterating a table that doesn't have a primary key? I could make a mistake. If you iterate the sales table, it is potentially dangerous to call a measure reference, because the sales table could have duplicated rows. You have a product, date, customer. The same customer buys the same product the same day. Oh, I enter into the store, I buy a bottle of water, then I go out, but 2 hours later, I want other water, I come back, I get the same product, the same day, the same customer, the same price, everything. And there are two different transactions that we want to compute. But what happens at that point? Well, because the context transition transforms the current row context into a filter context, it means that all the columns becomes filters. A context transition translates every column into a filter. And what happens if you have two rows that have the same value? In this case, we have 3 different rows with 3 different values. That's fine. But in case we have the same value in 2 rows, then think about this. The second row generates a filter context that includes 2 rows. But then the iteration over sales continues, and for the third row, it will generate the same filter context, computing the same rows multiple times. So we are inflating the result. This could generate errors. Writing a measure in an iterator that has a lot of rows could be expensive for the performance. But doing this in a table that might have duplicated rows could be also dangerous for the result that is not correct. So you have to pay attention to this, and you have to think that the context transition could be dangerous in these cases. Performing context transition over a table that has a primary key, one-to-many relationship, date, customer, product, not a problem. Sales, transactions, your fact table in the star schema, be careful. Possibly don't do that. Try to see if there is another way instead of iterating that table with a measure. Iterating the table using only column references, this is fine. Now, one last detail that I want to cover today is about the calculate execution order, which is, Marco, we have the filter, we have the context transition. What is the order? Well, calculate at the beginning evaluates the filters before anything else. But the result of the filters are tables that will be used later. So first, it evaluates the filters. Then it executes the context transition. Then it applies the filter modifiers, which means that all can remove the effects of the context transition, but the filter is executed before the context transition. And finally, it applies the filter to the filter context. If you go to DAX guide, if you want to get the list of these rules in more detail, I can show you. We have in the documentation of DAX guide, we included this list of detailed rules. So if you have any doubt, if you have a doubt about what happens exactly in this case, look at this documentation, which is an extract of the second edition of the DAX, the Definitive Guide to DAX book that will be available in a couple of months. So basically, I already shown you, this is just a recap of what we have seen. We can apply these techniques to obtain different calculations. I tried to show you maybe some example that was different from the one listed here. But the idea is that we have to think about the evaluation context as a sum of two elements, the filter context and the row context. They are different, they are not the same. The row context iterates, the filter context filters. The filter context is applied to aggregations, to table expressions. The row context is executed only for certain expressions in certain functions that you can retrieve in DAX guide, and of course for the calculated column. Calculate manipulates the filter context, but also transforms a row context into an equivalent filter context with a technique that copies a filter for every column of the table that you are iterating. And if you are iterating a table that has many columns, it could be an expensive filter. And if you are iterating a table that doesn't have a primary key, pay attention to the possible duplicated rows that you can have. Finally, remember that when you specify a filter in calculate, in a filter argument of calculate, you're specifying a filter over the expanded table, which potentially affects many other columns. As long as you remove a filter with all, that's fine. But if you write a filter with a filter, it could be dangerous and expensive. So pay attention to the details if you want to control the result and the performance of DAX. Remember to evaluate the session. Thank you very much. I probably have to run for the next session, but I'm available for you if you have any questions. Thank you very much.